In this lesson, we're going to look at exponential functions. So I think I want you right now to pause the video and go ahead and take your notes. All right, so the notes say that an exponential function is a function with this form right here. And I want you to notice, typically our variables are x and y, with everything else numbers. Well, in this case, a and b are our numbers. And take a look at where our x value is. It's actually an exponent in our exponential function, and this is very different from what we've seen before. We've seen functions where we have y equals x squared plus 2x plus 7, and our variables are down here in the base. Okay, but in an exponential function, our variable is up in the exponent. So let's see what that does in terms of what our graph is going to look like, what our exponential looks like when we plug in some numbers. Okay, so let's take a look at this very first example, and I want you to notice here our a value is missing, so it has the number 1 and it's positive, and our b value is greater than the number 1. Okay, so I want you to notice what happens to our graph when our b value is greater than 1, and I'm going to go ahead and use a blue pen to graph this. Okay, so let's plug in the number 0 and see what we get out. Any number raised to the 0 power is 1. So at 0, we are here right at number 1. Let's plug in 1. 3 to the first power is 3. So we'll graph that point right here. And if we square 3, we get 9. So at 2, we're all the way up here at 9. And if I put in a 3, we're going to go all the way off the chart to 27, and I don't want to count that high. So let's go ahead and start putting things in, and let's see what happens to our function as we go negative with our x values. Now we're applying a negative exponent, and I want to remind everybody that a negative exponent means we take the reciprocal of this number and then apply a positive exponent. So the reciprocal of 3 is 1/3, and we're going to apply a positive 1, which is just 1/3. So at negative 1, we're here at positive 1/3. So now let's apply a negative 2. An exponent of negative 2, sorry, that doesn't look like a negative 2, is 1/3. We take the reciprocal and we're going to raise it to the second power, and that is 1/9. So at negative 2, we're even closer to 0, but not quite there. What happens if we plug in a negative 3 for our exponent? That means we're taking the reciprocal of 3 and raising it to the third power, which is 1/27. And I want you to notice that as our x value gets smaller and smaller and smaller and gets closer and closer to negative infinity, this bottom number gets bigger and bigger and bigger. And that means that that number overall gets so close to 0 that you can barely distinguish that it's not 0, but it never actually reaches 0. And so we have a function that, oops, I missed that dot, but it kind of looks like this. Okay, and we call something like this a growth function, where we have the value inside of our parentheses here, a value that's bigger than 1. This is a growth function because it grows as x gets bigger. It's a growth function. Okay, and you can see that it's the y values keep growing and growing and growing. So let's go ahead and use green for this function here. And let's see what happens if we have, instead of having a number that's bigger than 1 in our parentheses, that we have a number that's between 0 and 1. If we put in a 0 here, let's see what happens. 1/3 raised to the 0 power. Again, I said anything raised to the 0 power is the number 1. So we are right here where we were for our other function. How about if we plug in an exponent of 1? We get 1/3 out. So at 1, we're at 1/3. How about if we have an exponent of 2? We are going to be at 1/9. And again, as our x value gets bigger and bigger and bigger, this number on the bottom gets bigger, which means our fraction actually gets smaller and smaller, and it approaches 0. So let's go in the negative direction and see what happens in the negative direction with a negative exponent. again, whenever we have a negative exponent, we take the reciprocal of this number and we apply positive exponent. So at -1, we're up here at 3. And let's go ahead and do a -2 and see what happens. We take our reciprocal and then apply the exponent of 2. We're going to get a 9 at 2, so we're up here. And you can see that if we pencil our graph in, it's going to look like this. And instead of increasing as x gets bigger, instead of increasing, our y value gets smaller as x gets bigger. It gets closer and closer to this y-axis, but it never really gets there. If we have a number in here that's between 0 and 1, this is called a decay function because our value gets smaller and smaller and approaches 0. And by the way, this line right here, our x-axis, is what we call an asymptote, has the equation of the line y equals 0, and it means as our x value gets bigger and bigger, or our x value gets smaller and smaller, our graph approaches that line but never quite makes it there. So let's see what happens if we have a multiplier in front. How do we actually do the calculations? I want you to remember, and what does it actually do to our graph? I want you to remember what PEMDAS says. PEMDAS says we have to apply our exponents before we do our multiplication. So here we're going to go ahead and raise 3 to a power and then multiply. So let's go ahead and plug these 5 numbers in and see what happens to our graph. And this one I'm going to do in red. So let's go ahead and plug in 0 as an exponent. And I'm going to put that multiplication sign there just so you can see what's going on. Okay, we're going to apply our exponent. Anything raised to the 0 power is the number 1. So we get the value of 2. Oh, sorry, 2. So at 0 here, we have a y value of 2. Then we're going to go ahead and apply our exponent of 1. Anything raised to the first power is just itself, so 2 times 3 is 6. So at 1, we're all the way up here at 6. At 2, what happens at 2? Okay, it's 3 squared. We're going to do our 3 squared first, which is 9 times 2 is 18. Okay, that's off our chart, so I'm not going to plot it. I'm going to go to our -1 power. 2 times 3 to the -1. Remember, a negative exponent means we take the reciprocal. So we're going to take the reciprocal of 3 and raise it to the first power, which is just a third. So 2 times a third is 2/3. So at -1, we're here at 2/3. And let's go ahead and do -2, which means we have to take the reciprocal of 3 again and raise it to the second power. 1/3 times 1/3 is 1/9, so we have 2 times 1/9, and our end result is 2/9. And here we're at 2/9. We're pretty close to the y or the x-axis, and when we pencil it in, it's going to look like this. So again, it's still a growth function, and that's how we do our calculations. And you can see our values. Our value here has totally changed because of this multiplier. This curve is steeper than our original curve over here with just 3 to the x power.